Hi, my name is Asif Khan, and I am a cloud solution architect at Microsoft. In today's session, we will be talking about Azure Container Apps. I think from the top, if you look at it, looks like another container services in the Azure ecosystem, but I can be very truthful and I can tell you confidently that it was not just for the sake of adding. The product team had deep insights on why this service came into the picture. Now, obviously, we all know that there are pretty much wide range of different container services which are available in Azure. Some are managed, some are PaaS, and then you can also build and deploy your own container ecosystems in Azure. So with respect to the most popular ones, we know that you can deploy a container, you can deploy container apps using app service, you can deploy containers using Azure Kubernetes service, which is again the managed Kubernetes environment in Azure. It has all the features which Kubernetes provide, and on top of it, it's totally managed. Now, if you want to go on the lighter side, then we have this Azure Container Instance, which is still very popular and was a big boom when it came out. The good part about Azure Container Instance is that it is a silos container model. So you basically create an Azure Container Instance, which is a platform as a service offering from Azure, and that one particular container instance, you will provide your container and that will be executed. It's highly useful for long running jobs and things like where you might be needing some microservices where you just want to deploy them as a PaaS service. With all the VNet integration and network integration options aligned with Azure Container Instance, it gives a lot of capability and feature. But again, it misses a very important aspect about the scaling concept. So if let's say you have 5 microservices running in Azure Container Instance, you have to individually manage the scalability of those different containers because as a total, uh, that each container is its own silos and it is independent of other containers. So that is where which we have a sweet spot where Azure Container App came into picture because the important aspect is, let's say you are having a web application which has, let's say, 3 tiers: front end, middle tier, back end, and in the middle tier you might be having, let's say, 5 different microservices which are serving your front end and talking to the back end as well. And let's say if you have a boom of traffic because of year end or Black Friday or whatnot, then in that case you need something where the entire stack, the middle tier stack scales, not individual services. And that's one of the good use case why Azure Container App basically is about to solve. Now, be mindful that this service is currently in preview and it is available in limited regions, but obviously it is going to come out very soon as GA and in almost every region in the world. Uh, there are a lot of different other use cases as well, which I'll show you. They are also available in docs.microsoft, so I've just used the images from there. So nothing fancy about it. So going ahead, I'll just quickly show you what are the different use cases which the product team came up and the documentation team has provided on the Microsoft Docs. This is the image from Microsoft Docs. As you can see, the most primary one is about the public API endpoint management with something like a Canary deployment where you can basically split your traffic between your production and your new revision workload, 80/20 and stuff like that. Or you want to do a blue-green deployment, that also is definitely possible. Background jobs and processing, again, it had been also solved by ACI, Azure Container Instance, but over here we get the scaling is basically built on top of the CPU and memory load. The most interesting one is about the event-driven processing because what Azure Container App comes up with is deeply inbuilt with on top of CADA and Dapper. Now, CADA, if you're not aware of, CADA is basically Kubernetes event-driven auto scaling. Now, in the Kubernetes ecosystem, the pods concept was there, and then obviously the pod gave you that leverage of horizontal scaling in case of requirement or like a lot of overload for of the request. You can horizontally scale your pods and create n number of pods so that you can process the request. Now, that scaling definitely needed some different criterias, and then you would have to configure those criteria in your Kubernetes infrastructure. With CADA, which is obviously was created within Microsoft by the incubator group, Office of CTO team. What it gives you is it gives you that scaling capability based on the different components or different services which might be inside Azure or outside Azure. Now, some of those services can be a SQL database, it can be a MySQL database, it can be a blob storage, it can be a service bus, it can be Kafka cluster. So there are a lot of different integrations which are available in KEDA, which integrates your yeah, in your container ecosystem, whether it's Kubernetes or Azure Container App. Container App comes natively with KEDA, so it's a very good feature. And then Dapper as well, which basically just manages your distributed application and microservices without giving you any stress. So if you're building a microservices with different technology platforms and you have an overhead of how to make that communication and conversation smooth, Dapper is basically a sidecar pattern, and when you deploy a microservice with Dapper, it is basically a sidecar. Dapper sidecar gets created in within your microservice, and all the conversation and communication is all managed by Dapper. Not only just the communication conversation, it also has a lot of different features, things like managing your security, things like retries, and things like that. So yeah, Dapper and Keda itself is a big topic to discuss, but yeah, this is all pretty much baked into Azure Container App because all the considerations were made that you get this one unified service which would solve mostly all sort of your application build, deployment, and management scaling requirements. So going forward, what we will be focusing today in this session with the limited amount of time we have, we will be looking at the revision capability which are available in Azure Container Apps. Now, the Container Apps has different models, how the application, the containers are deployed. By default, when you create a container app, which I will be showing you on the portal as well, it basically comes up with your container app environment, and then inside the container app environment, you can have multiple container apps. Now, in that container app, by default, when you create a container app, you need to provide your container image, which might be from your private repository or your public repository like Docker Hub. And once you provide that container image location, the container app during the provisioning process downloads or gets that image and create a default revision one for you. So you don't need to create any revision one. Now the magic comes up when you start to create new versions or you update your application with new details. And that can be for one particular component. So let's say if it is a middle tier example, which analogy which we took earlier, it has a couple of different services. Now, let's say you make changes in 5 of your services, and then there are new features added to each of them. You can create a new revision, which would be a full package of those 5 services, not individual service. So this is a very good feature where the entire stack is basically revisioned instead of individual services. So what you can do is you can have multiple revisions. Currently, the number which I can see on the Azure portal states that it can go to Azure portal or docs.microsoft states that it can go to up to 100 revision, and then after that it's purged. But again, that will go on growing in future. So what we will be focusing today is about this revision concept and how we can use this for our Canary deployment and test the different version of application. So next, let's go to docs.microsoft and let's have a quick glimpse of what is available over there. So as I told you, I've already, I've used the image from docs.microsoft. So yeah, this is the same image which I showed you on the whiteboard. As you can see, it talks about all the different revisions and stuff like that. And then once you have different revisions, you can basically just manage your traffic and make your version or production revision getting the 80% traffic, and your new version, which is the latest code base, you can get your 20% traffic to get all the telemetries and if there are any errors or bugs before you productionize it. As I also talked about that the current limit is up to 100 revisions, so you can create 100 different versions. Now coming back historically, if you remember when the API ecosystem or the API real estate started to come into picture, the one of the biggest challenges challenge was how to manage that compatibility of different consumers running on different API version and how to keep that backward compatibility to n or n minus 1 or n minus 10. So this revision capability coming out of the shell, out of the box for Azure Container App is a really good opportunity where you can run multiple revisions of your application, keeping all your customers active and available and consume it. And also it's really good for your blue-green deployment as well as Canary deployment, which makes things pretty simple and straightforward. If we look at the um, good documentation is there around the comparison. So Azure team they and the documentation team they knew that it would be a big confusion about all the different services like app service, container instance, Kubernetes, functions, and Spring Cloud already available for managing the container side of things. But then additionally, we have this Azure Container App, which might be a little bit confusing. So if you read through this, you will get to know what are the specific use cases and how Azure Container App differentiates itself from all these existing services. Coming last to the pricing side of things, as you can see, just like any other Azure PaaS services, it is extremely cheap. Um, there are 2 million free grant requests, so you can think about any medium-sized application would be pretty much good with the free tier itself. And then on after that, there are vCPU and memory-based costing. So again, a lot of free grant available upfront. So yeah, for any sort of POCs or even for lightweight production deployment, I think so it would not be a challenge to just get done everything into the free tier without even spending a dollar. So let's now jump onto the portal and let the rubber hit the road and see the things in action. So if you want to create a Azure Container App, it's pretty straightforward. You go in into the create resource and just type Azure Container App. It's available. Uh, Let me just container app. Yes. Yeah, as you can see, it says preview. So yeah, just be mindful that it's still in preview. And yeah, if you're planning to deploy production workload, it was not recommended to deploy production workloads on a preview environment. So what we will do is I'll run you through a wizard on the portal itself. Nothing is stopping you to do it through a CLI. Let me quickly switch gears and show you if you want to do whatever I'm about to do on the portal, you can do it using CLI option as well. So this is just a bash command which you can create, and it's all again coming from the documentation quick start guide. So if I just quickly zoom on this. Yeah, so as you can see, it's pretty straightforward directly from the CLI itself. If you want to create again, the Azure Container App is dependent on log analytics because monitoring is definitely required for any container deployment. So yeah, first you need to have log analytics workspace, and then as I told you, container apps run on top of a container app environment. So firstly, an environment is created. This is pretty much what I can feel is very similar to app service environment. Yeah, app service environment sort of thing. And then you have an environment, and then on top of it, you can create multiple container apps. So that's very straightforward. In the setup or the configuration side, you provide your image details, and then also you provide your ingress, whether you want to have a public expose endpoint or want to have an internal endpoint, and then you also provide what port. So that these are pretty straightforward stuff which would be required to set it up through the CLI command, but we will just create that through the portal, which is more intuitive. So let me just quickly zoom this. Yep. So I'll just so first thing what it is asking is to create a container app, and I need to select a resource group. So I'll use my existing resource group, C app resource group, container app resource group, and then it needs a name. So I'll just use a container name. So couple of things. What I have done before starting this session was I have created some simple application, but I'll show you in a click before once we create this, then I'll show you that. So I have K8 web uh, Docker. Let's use that name. And as I said, every container app is built on top of app environment. So you can have you can create use existing. I'm using existing one, but you can also create a new one. So if you create a new one, it is very simple. It just asks for your name, environment name, and then as I said, it's currently in preview and limited region, so it's only available in these three regions. So you will have to live with that. And then on top of it, the environment is also connected to a monitoring system, Azure Log Analytics Workspace, so that you can get all the deployment and your container monitoring directly ingested into these monitors. So you can create one or you can use the existing one. In my situation, I already have one container app environment, so I'm just going to use that app in ENV. So that's it on the basic side, and then the next is important one where we will be providing the details of our image. So firstly, it asks for what name do you want to give. So I'll just say it is web um, RC1. So that's my, let's say, release candidate one. Now, where exactly this image should I be pulling from? So I've put everything on Docker Hub so that it will be easy for you even if you want to replicate this. And let me quickly take you to my Docker environment. So this is my Docker Hub environment. And if I go inside K8s web, so inside this, I have two different versions. So I have RC1, RC2. Now, the interesting bit about this two different versions is they are exactly the same code. And I'll quickly show you in a click what the code looks like. But the only difference is, and I've also documented it over here, is that RC1 has a message which says V1 and RC2 has a message which says V2. So let me just put the details for the image and then I'll just start the creation process, and then in the background we'll go and see what this project Kate web looks like. So I'll click on RC1, or maybe I'll go back and I'll say select all, and that should give me my RC1 uh, Docker. Yep. So I'll just take that. Obviously, you don't need to put the full pull command because, yeah, Azure Container Instance Container App will automatically download that. Now, what it's saying is, obviously, I'm using Docker Hub. You can also use Azure Container Registry, or you can use any other registry if you are already using something else. And then I provide my image and the tag details. And then if you have something like a prerequisite command, something like sleep echo, or let's say database seeding or something like that, you can also do all of those stuff. CPU and memory again is a good one because there is a number of different options which you can select based on your application specifications and requirement. The list is, as you can see on over here, obviously it will be growing eventually with time. Now, the last and important one is obviously about the traffic. So how do you want to interact with this particular container app? So it says if you can have it all internal without any external expose, I would expose it externally so that we can access and interact with it. So I have enabled ingress on this, and then I'm exposing it external. And the last one is it is asking for what port will my application be listening on. So I'll say it's on port 80, and then I'll say next. I won't use any tags for now. It would do a validation check that all the information which I have put in, it's all valid, and then I can just click the create. So in the meanwhile, while this creation process is happening, I'll take you to the application which I was showing you on the Docker environment. So this is my Visual Studio Code. I'll zoom it a little bit. So yep, that's good. So over here, if you can see, this is the simple web application. I've just written it in um, .NET MVC, .NET Core MVC. There's nothing fancy in this. At this stage, it has just one view. In that view, what I have done is I have created in the index file, which is all default. I haven't created anything specific. In the index file, I have a message that says welcome K8 V1 sales application. And in the version one, in the RC1, release candidate one, which I was showing you in my Docker environment. So let me go back over there. So I have two different tags. So we have RC1 and RC2. The RC1 basically has the message, which is what you're seeing at this stage, V1, and the RC2 tag will have the V2 message embedded in it. So that's the basic difference. Now going back to the code, apart from this, there's nothing else in the .NET code side. This is the Docker file. I have checked in everything into GitHub. The link for the GitHub will also be available in the document in the message in the post. So below the video, you can see there is details around the GitHub repository. So once you have cloned the repository, you just need to like get to the path of your application, and then using this, you can build the application. This will help you in running the application locally. And then the next is you might need to push it to Docker or wherever repository you want. I have just added the code for Docker. So it first tags and then it pushes. And then if you want to test it again, you can pull it from the Docker hub environment and then run it and check it locally. So this part is for the version one, and this part is for the version two. So again, if you use Docker and if you have used container build scripts earlier, it's pretty straightforward. And on the .NET side, I have just again, this is the default Docker file where I haven't done much apart from creating a multi-stage Docker file so that I have a smaller image. So what it is saying is it basically firstly gets the .NET Core 3.1 version. I did it a while back, so it's still using 3.1. Currently .NET is on 6. It first does a restore on the web application, then it does a build, and then it does a publish. And then once the publish is done, the last stage of the Docker file is last stage of Docker file is about just packaging it and exposing the application on port 80. And .NET, this is the entry command, so it will basically initiate the DLL. So yeah, it's all pretty regular stuff on .NET Docker application. So on the code side, there is nothing else which I can show you. And this is the two different RC1 and RC2 of my Docker images, which are over here. So RC1 will have V1 message, RC2 will have V2 message. So let's now switch back to the browser and see maybe our application should be deployed by now. So let me switch the browser. So yep, so we are back over here. So yeah, that's good. Everything is in green. Now I can go to the resource. So this is the K8 Web Docker container app, which is created. Now, if we get into the revision, as I told you in the starting of the session, that yeah, revision is something which is by default, revision one is created for you. You don't need to do anything for that. When you select an image, it basically creates the image or revision one for you. So as you can see over here, this is my revision one. All the traffic at this stage is going to this revision one. Provisioning status is all good. Sometime you will see that it will be in processing state, which means that there is some issue or some problem is there. Now, if I click on this, it will take me to the revision details. And so once it loads, basically we will be able to investigate and interrogate what are the different containers running inside it. So at this stage, you can see because I exposed it as ingress, public ingress. So I have a FQDN public endpoint, which I can click and I will be able to access the application, which I'll do in a click now. Before I go there, I can show you the containers on top of which this Azure Container App is running. So this is my container details. It's using my RC1 tag from the Docker. So the RC1 is this, which should have a message V1. And if I further want to navigate or investigate inside this, I can click on that. and then that should open all the details which I did provide at the time of creation. So as you can see, this is getting from the Docker Hub. That's my K8s Web RC1 image and tag, and it's a Linux environment and all the defaults which I did set up when I was creating it. Now, on the scaling side, as you can see, by default, there you can scale from 0 to 10. So there is a scale which I haven't set at this stage, but you can definitely do that. And then it also have pre-built Dapper support. So you need to enable Dapper support as well when you are creating the container app. In this demo, we are just going to look at the revision side of things and Canary deployment. So I haven't enabled Dapper, but yeah, that is all pretty baked inside the Azure Container App environment. Now, if I quickly click on this, that should take me to my app. Initially, it takes a little bit of time to because it needs to warm up. Obviously, the app is running and everything is there, but yeah, the first request is a little bit slow. There are some of the reasons which I can think of. Firstly, I am running this application in North Europe, and my physical location is Australia. So again, there is like a location challenge, and then obviously it also needs some time to heat up, and thirdly it's in preview, so we have to be mindful about all that things. So as you can see over here, this is the v1 message which I'm getting for my rc1 image. Now what the plan is that what we will do is we will deploy the second version, which is the RC2. So we will also go and deploy the RC2 image, and that would basically have the message V2. And we will run both the V1 and V2 in parallel, and then we will basically split the traffic as well. So what I'll do now is I'll come back, and this is our container app environment. So over here, as you can see, there are different things. So let me just quickly show you the ingress also. This is exactly the same what we did set up. So there is nothing changed or no additional features. So I'm having an ingress enabled, and then I'm having external, and it's on port 80. You can also have continuous deployment using GitHub or integration with GitHub or Azure DevOps. Again, it's all very straight, similar to any other container deployment options. It's exactly the same. So yeah, so you can use your continuous integration and continuous delivery using the continuous deployment options as well. Coming back to our revision, so what I'll do is we already have deployed the RC1 version. So we have the RC1 there. Now we need to deploy the RC2. So in order to deploy the RC2, what I will be doing is I'll quickly just copy the names and stuff from our existing revision so that it is aligned instead of me creating some random names. Uh, what I have seen is, again, because the service is in preview, again, this will be much better when it goes GA. But being in preview, I think I see a little bit speed of the load and everything is different compared to all the other applications, other services in Azure. But again, this might all be just because of my environment or my particular subscription. But anyways, at this stage, it gives a lot of good features which are more important to focus on than the speed. So I'll just say I want to create a new revision. So there are different things, different uh, basically components which you need to think about. So a revision can be an application revision or it can be a container revision. So there are a couple of different things around that which we can discuss later. So firstly, you can see, as I said, I'm creating a new revision. It by default brought in the RC1 itself, but I want to bring in a new container version instead of taking the existing one. So what I'll do is I'll say container image. I'll just get the RC2 image for my revision 2. So what I'll I'll basically use my Docker environment, Docker Hub, and now instead of RC1, I'll say RC2, and I'll just use the name very similar to what we did for RC1 so that it's easy to understand. So that's my gate is, and this is RC2, and that's RC2, and I'll keep all the rest defaults. Again, you can have all these different configurations which you can select. So that's my public. I have a Docker Hub repository. This is my RC2, and that's my image tag RC2, and so everything looks pretty good. So I'll click add, and now as you can see, I have this new container image added. Now the next thing is I need to click the create so that it start the create process. As I told you earlier, you can enable Dapper. So at this stage, it's not enabled, but when you're creating your container revision, you can create that, or when you're even creating the container app, you can enable Dapper on top of it. On the scaling side, from 1 to 10, that's the scale limit at this stage. It also supports Kera, so you can have that unlimited scale with Kera as well. So next I go to scale, I'll leave all the defaults, and then I'll go to Dapper, I'll say again defaults, and then I'll say create. So once so the creation process started, and then we should also see something in progress over here. So once this loads, yes, so I can see there is a provisioning option over here, and this is our old revision which was already available. So this doesn't take long, it should be quick, and we'll come back once this is done. All right, so it looks like the deployment is successful because I can see the processing has been done. So if I refresh this, very good. So now I can see I have two different revisions provisioned, but it's very hard to understand from the top, like which has my version 2 and which has my version 1. So yeah, so first thing is we can go inside this and then we can look into the container which are running for the currently newly revision. So this should show RC2 at this stage, which has all the 100% of the traffic. So it should, yep. So as you can see, this is my RC2 tag, and that's my container endpoint. Details will be available over here, which should be my Docker container Docker endpoint. So Docker Hub details would be here. Yeah, so it's my web RC2. So that's my newly created revision with the latest version of my container app. Now, in order to test this, let's go back. And the good part is you can see by default it has already set 100% of my traffic to the newly created instance. And if you look at the time as well, this is something we created at 6:02 as per the I think, so UTC time. This is created at 6:13. So this is the latest one, and it has all the 100% of traffic. So I'll go in the overview section because that's where we have our endpoint FQDN. So it might be that it would be cached because of the static app, but let's see. Hopefully we should get V2. All right, perfect. So we got our message V2, and this is the earlier endpoint which we opened V1. So at this stage, if I go back into my old endpoint, which is the same as this one, it should be updating to V2 as well. So it's just, yeah, refreshing the browser. So once the browser refreshes, hopefully we should have the updated version presented over here. Okay, so let's see. Yep. So So at this stage, if I look at the endpoints, so if you look at there's a difference between the two endpoints because this is still targeting the old endpoint and that's the new endpoint. So yeah, so again, it's not like pointing, everything is getting pointed to the latest deployment. If you are using the old URL, you will be heading back to the old version. But all looks good. If I come and refresh this, again, I should have this as V2, which is my latest revision, and this is my old revision. Now, what next we can do is we can do the test on this. And how we can test that is if we go back into the revisions and let's say what I'll do is I'll just switch the traffic. So I'll make my older revision, which is my RC1 uh, container, which is running the message with the details as V1. and we will just validate that. So PZ5G74D, that's my older deployment, and that should have RC1. So once this loads, we should be able to validate that. And then what I'll do is I'll basically put all the traffic to this older version. And yeah, so this is RC1. So what I'll do is I'll just put all the traffic back to my previous container, old container, and then the new container, I'll make all the traffic at 0. So what will happen from this is once this save process completes, we'll go back to our endpoint, and once we click the endpoint, we should see the message as V1 instead of V2. So we haven't changed anything on the endpoint. The only thing we have changed is the traffic on the revision. So this should load. Okay, so maybe I click the cross. All right, so let's go back. Yep, and I'll just quickly, once this loads, we should have the endpoint, which I'll click. Maybe my internet is also not that good today. So yeah, it might be the reason why this is loading slow. So I'll click on that, and that should basically navigate to my V1. So this is taking me back to my V1. Now let's see if in a real world we want to do a Canary deployment where I might go with let's say some percentage of my production traffic to the new version and some percentage to the rest of the traffic to the older version. So this is my older version production. All 100% traffic is going out there. Just to see a toggle experience, I'll just change this to 50-50. Hopefully, we should have that toggle experience of message presenting V1 and V2 once the save process is completed. So yeah, so I think the good part about this entire execution and entire revision concept is you can go to a level of 100. So you can maybe you can imagine like if you are running something like a DevOps process and you have every now and then the build goes out and you want to manage that at the production level instead of release level, then this is the best possible way because you can have all the different revisions sitting over here without any traffic hitting them. But at any point of time, you can switch on those deployments and then just pass the traffic to them, maybe 5 or 10% of the traffic, and then you can see what sort of challenges or errors might be coming up, and then you can mitigate them and come back and make it fully productionized. So in the meanwhile, I'll quickly open another tab. I want to show you the logging side of things as well. So what we'll do is we'll come over here, and so this should load with V2. Yep, so it did load with V2, and I'll just open the browser for our logging. So if you remember when we were creating the Azure log analytics workspace for our app container app environment. That log analytics workspace was injected into the container app environment, and then all these container apps which we have created, they get logged into that log analytics workspace. So if you want to validate any telemetry, any errors which you might be getting, you can validate that pretty easy. So if I refresh this, yeah, if we are lucky, we should get to see yeah, so see, the same endpoint we are able to toggle because of the 50-50 traffic which I have set up. So now it's V2, and if I click V1, again V2. So yeah, it's pretty magical. So now it's loaded. So let me go into my container app resource group, and inside the container app resource group. So there are a couple of options how you can navigate to your log analytics workspace. So firstly is you can directly go to your log analytics workspace and you can access it from there. Or the easy option is you can click on the container app logs, and that should open that segment of log analytics workspace where you should be able to run your queries. So yeah, so you get the query and query viewer. The interesting is bit is you have to go into the custom logs because it is not part of your log management side of things. As you can see over here, I have a container app console log underscore CL. CL is custom logs. So I have just clicked on that. There are pre-cooked queries as well, which some of which I run historically. But yeah, so if I just double click on that, it will automatically populate this. If I run this, it should be bringing up a lot of different uh, telemetries from the app environment which we have, Azure Container App we have created. So yeah, so that's it has around like 950 items. Now, if you have used Login Workspace, this is CustoQuery. So CustoQuery is a query language which you can leverage to query those Login Workspace logs. In this situation, we are accessing the container apps log, which is basically it will give all the internal container telemetries. So all the telemetries which are created inside the container, they are basically popped into the Loginix workspace, and you can go and investigate that if you are experiencing any issue. So just to simplify this, you can go and it's very similar to a normal SQL query if you have written. Um, just this a little bit of indentation is different. So I'll say I need to uh, time generated, which is my first column, and order by time generated, the descending, and I just want to, no, not this, I just want to project, uh, so I want to project only log underscore s. So that's a pretty simple query. What I'm saying is I want to order by descending so that the last log comes first, and then I just want to see this column instead of all the columns which I had to scroll through. So if I click on that, it should basically come up with all the logs which have been created till now. So if I open this, you can see it gives me the internal ASP.NET telemetries. And then if I hosting environment production, so these are all logs coming from the container itself. So as you can see, this is the new, I think so this the new revision which we deployed. It says now it's listening on port 80. Application started. So yeah, it looks like this is the revision 2 with the RC2 image. Once we deployed it, that's where all these telemetries came out of. And then we should also have some telemetries from the application is shutting down. So this is where our primary application would have shut down. So yeah, you can go through these logs and get all the details. If there were errors, you'll get more insights on where the containers are failing and all that details. And then you can leverage that to basically mitigate those issues or fix the issues which you are encountering. So yeah, so that's a very detailed insight. Again, you can have your advanced queries and stuff which you can write on top of it, and yeah, that can help you in creating alerts and all the other stuff associated to it. If okay, that's let me go back to my container app resource group. So if I click on that, then I should have yeah, app environment. So I was just trying to show you the app environment side of things as well because we didn't visit that. So inside the app environment, again, it's very similar to Azure App Service plan. So if you look inside this, it has just the basic things, and then inside the apps, you can see we have two different apps. So we have KDS Web Docker app, and then we have this is another app which I created. Now that's where we did all the magic today, and that's where our two revisions are also working. So the two revisions we created with RC and RC1. So yeah, the RC1 and RC2 are both available in our revision side of things. So in a nutshell, what I can tell you is container apps is Definitely something which you can look forward for your production implementation. So yeah, those are the two App1, App2, RC1 and RC2 with 50% traffic. So what I was saying is, yeah, it is really good container service where you can package your entire application in one go and have those all the scaling and all the goodies for your entire application stack level or the entire app level done in one go instead of individually managing the scaling and horizontal scale for your containers. So this is really good. And just to conclude, I'll also show you something on the docs.microsoft. Let me just switch. So I would highly recommend to go through the docs.microsoft.com documentation for Azure Container App. It has very detailed documentation of what are the different things around the scaling, CADA, and stuff like that, and also the Dapper component, which we did talk about for the microservices. Whatever I showed you today, that's all available in my GitHub repo. So this is the GitHub repo, which I'll be providing the link within the video as well. You can go and get the code. So this is the .NET code. And then this is your, if you want to deploy it through the bash, this is this script for CLI based deployment for your container app. And this is the Docker file which I was showing you where you can just download just pull the code and just build it. It should run pretty straightforward. Just be mindful that you need to fill the local path and stuff like that. Once you have done that, you can run it all through that. If you want, you can use my current Git like Docker Hub repo as well. So you can get the images from there. It's all public images. So yeah, it is definitely you can access that. You can use this if you want to simplify it and you don't want to get into the hustle of just down pulling the code and building and doing all that. And then you can do all the magic from the Azure portal itself without any challenges. So yeah, thanks a lot for watching this session. Hopefully, Azure Container App will be a great help for you in coming time when you are trying to build a web application or any sort of application which needs scale and need microservices implementation. So it's something which definitely you should keep an eye on and look forward to for your future implementation. Thanks a lot for watching, and please put your comment suggestions. More than happy to get some insights on what should be improved or what can be better done. Thanks a lot for watching today. Have a good day.